My name is Helge. I work as an assistant professor at the Research Center for Government IT at the IT University of Copenhagen. I would like to present my paper, What Constitutes Software, an Empirical Descriptive Study of Artifacts, for this year's MSR conference. Do we really have to study what is software and what constitutes software in 2020? Is not the term and concept of software well understood? We are using software every day, and the concept has been around for more than 50 years now. I believe the concept of software is still not well understood today. First, there doesn't seem to exist a standard definition of software. Likely everybody in the audience understands something different by the term. Second, neither literature, industrial standards, nor standard contracts seem to provide a consistent definition of software, nor a practical definition of it. What do I mean by practical? I believe there is no definition of software and no precise definition of its constituents that supports practitioners that are responsible for negotiating and signing software sourcing contracts. These people are often generalists. That is, they are not software engineers or developers by education. So they do not necessarily have an intuition for which artifacts might be considered a deliverable in a software sourcing project. For example, we know of cases where customers could deliver a system source code without the complete build specification and without the build executable. And since source code alone is unusable, build code, also both build code as well as executables, should be considered constituents of software. Common definitions which generalists might rely on, such as the one from the Oxford Dictionary of English that you can see here, are too generic, and they do not provide any guidance when deciding on concrete deliverables. Therefore, we studied industrial standards, standard contracts, academic articles, and we conducted an empirical experiment to better understand what software actually is and of what it is constituted. In the following, I will present some key findings from studying the standards, the contracts, and academic literature before presenting our experiment. Please find deeper descriptions and more details and more examples in the paper. What do now the standards actually say? We have studied various industrial standards from the software engineering domain. Even though they define the term software, the standards do not make it completely clear what constitutes software. The standards seem to agree on that programs are fundamental to software and that software consists of a number of artifacts such as programs, documentation, configuration, and so on. However, the standards seem to disagree on which artifacts precisely constitute software. For example, are graphics and databases software or aren't they? As an example, the IEEE standard for configuration management defines software as computer programs, procedures, and possibly associated documentation and data pertaining to the operation of a computer system. That is still quite close to the definition from the Oxford Dictionary of English and still quite generic. The ISO 19770-5 standard defines software similarly, but it adds the distinction, and I think this is a really interesting distinction, for executable and non-executable software. So here they say there is non-executable software such as fonts, graphics, audio, video recordings, and so on and so forth. The ISO 19770-1 does the same, but it excludes information such as graphics and databases from being software, as you can see in the definition. That is, our software engineering standards cannot serve as a guide to decide which artifacts constitute software. What do the contracts now say? In some countries, public agencies rely on prescribed standard contracts for software sourcing. For this paper, we studied the British Model Service Contract and the Danish standard contracts for small, large, and agile software sourcing projects, since we were expecting to find a crisp definition of software and its constituents. We as non-lawyers, we also thought that the contracts that care about software as the actual product must be explicit about what this product actually is. However, the British Model Services Contract and the Danish contract for small software projects, K01, do not define software at all. And the other two Danish standard contracts define software recursively and inconclusively. For example, if you look at K03, the standard contract for agile software projects, it says software consists of customer-specific software and or standard software, also including interfaces. Then it says customer-specific software is software that is not classified as standard software. And then it says standard software is software that is neither customized, adapted, nor developed specifically for the customer in connection with the supplier's fulfillment of the contract, and partly available to anyone on ordinary commercial or non-commercial or equal terms. That is, now, what you can see in these definitions is that they're still quite unconclusive, as it's not clear which artifacts now precisely constitute software, and of course they are recursive, as a software is software. In the paper, we actually provide an initial overview of all the artifacts that all the contracts talk about, and they are actually explicitly mentioning certain artifacts, and that is really interesting. And it's also interesting that all the artifacts that they mention, as they are mainly focusing on documentation artifacts, certain kinds of documentation like operator documentation, user documentation, and so on and so forth. What do the academics say? Interestingly, articles that are concerned about software engineering do not really care about what software is. That is, they care about what the engineering, but it remains unclear what precisely is engineered. Other definitions, such as the one from Somerville that you can see, are mere lists of potential artifacts. As you can see, Somerville nicely says software is more than just computer programs, but also all associated documentation and configuration data that is required to make these programs operate correctly. And this documentation may include system documentation and so on and so forth. So that is, as there's a number of examples presented for potential artifacts, but it's not clear which other artifacts are there, or which other artifacts might be required. And then there are also academic articles that provide an answer to the precise question, what is software, as we found actually too. And they also provide definitions, or deliver definitions of software, and they're extremely interesting, but unpractical when negotiating a contract. As you can see, Suber's definition here, Suber defines software as pattern per se, or syntactical form, and then says hardware in short is also software, but only because everything is. And it's a really interesting article, and it makes, when you read it, it makes a lot of sense, but it's absolutely not practical when you're a practitioner that has to negotiate a contract. No. What does empiricism say? Now, we thought, let's have a look at what people consider to be software to learn more about what software is and what it is, of what it is constituted. And we actually figured out, this is a result now already, as it's at the end of the paper, we figured out that software is the collection of any of the 19 artifact types, so concrete artifact types, source code, specific source code, script code, binary code, and so on and so forth, that humans collect and store. And clearly, these artifacts are more than just code. Documentation, this is a finding that we have, documentation is an integral part of software, and depending on the domain, data is not necessary for software. Furthermore, we find, even though rare, code is not strictly necessary for software. But how do I know? Like a natural scientist, I had a look at a lot of what people consider to be storages for software, that is at software repositories, and automatically analyzed what they contain and in which distribution. The experiment relies on collecting 23,715 repositories from GitHub and letting two standard tools, the file tool and the drawer tool from the British National Archive, classify each artifact in each repository. For the data that these tools generate, we manually and incrementally developed categorization rules. This is the box marked with the asterisk. After we manually and incrementally implemented these rules, then of course this box runs automatically and automatically categorizes each artifact into one of the 19 concrete categories that you see here listed in the illustration below. These 19 concrete artifact categories are organized into the 4 high-level categories: code, data, documentation, and other, as illustrated on the slide. For example, any file that contains a header line specifying its interpreter is categorized as script code, and files such as makefiles and maven files are categorized as build code. The paper provides more details for each category and what we categorize as what and how we actually do that. Let's have a look at some of our results. Actually, and quite nicely, we can confirm Somerville's conception of that software is more than code. As you can see, the vast majority, over 90% of the repositories, contain code, data, and documentation artifacts, as in our high-level categories. Even though software is more than code, we can see or we find that various forms of code, such as source code, script code, build code, etc., is still quite prominent in the repositories, or not still, but is quite prominent. Usually with a median of 67%, 2/3 of a repository are code, almost a fifth is data, and around a tenth is documentation. Software is also really diverse, as you can see in the table. The most frequent concrete artifact category combination consists of 11 categories, and less than 4% of all repositories in the dataset possess it. In the table, you can also see that the relative occurrence frequencies of the next 4 most common concrete artifact category combinations are even lower. That is, likely one cannot characterize software by a certain combination of concrete artifact categories, as since all these relative frequencies are so low, as there's a really long tail of low occurrence frequencies. We find that documentation is an integral part of software. The orange bars in the illustration show that the majority and almost all of the repositories with artifacts of at least 2 different concrete types also contain artifacts that we categorize as documentation, that is, prose and legalese. Does software without data exist? Yes, it seems so. Circa 7% of all studied repositories do not contain any data artifacts. We did not expect that in the beginning, but when we were thinking about it and inspecting it more closely, it also makes sense. For example, we found software libraries, and they usually don't contain data as separate artifacts. Similarly, system-near software or scientific software likely collects or generates all the data that is needed during runtime, and the rest of the data that is needed is very likely organized directly in source code now. And surprisingly, and also quite rarely, software without code seems to exist. The corresponding repositories could be either regarded as informational artifact libraries, for example, for sharing artwork or knowledge, and the latter also conforms to Osterweil's conception of software that is not meant for computers but for humans, such as tutorials and manuals or link collections that we found. Originally, we thought that software is characterized by a particular distribution of artifact categories. That is, we thought that software is usually mostly code, a bit of data, and a small amount of documentation. However, we learned that this would be the blue line in the plot now. However, we learned that this distribution exists for only less than half of all the repositories that we studied. The remaining repositories show all kinds of different distributions, such as more data than code and more data than documentation, represented by the orange line in the plot. That is, our answer to what constitutes software is actually that for sure any of these 19 concrete artifact categories, so artifacts that fall into these 19, so this is now, unlike the other definitions, not an exemplary list. These are really all the artifacts that we found, and we found, also for each of them, we found represented artifacts representing these. Finally, if you want to better understand how all the numbers and figures in the paper are created, there exists a Jupyter notebook GitHub that you can use and play around with. And also the entire experiment setup is available in the same repository in case you want to replicate or rerun the experiment today. I thank you very much for your attention, and I'm looking forward to our discussion session soon. Thank you very much.